Hey everyone, it's time for us to start talking about metrics. Metrics, or the composite metric that's employed by EIGRP, is used to determine which prefixes learned via EIGRP we're going to place inside of our routing table. Now what I want to do is I want to go into our topology here, and what I've done is I've removed all EIGRP configuration. What we're going to do is I am going to go ahead and recreate our topology where R1 is going to be connected to SW1 and SW2. I'm going to create a loopback and I'm going to advertise it, and then what we'll do is we'll just finish the connections such that we're able to start sending prefixes to R22, the data center that we've been using up to this point for all of our discussions. Now what I'm going to do is I'm going to do the basic configuration again. Yes, this is a repeat of what we've already talked about in the first video, but now what I want to do is that we've covered all of the nuances to bringing prefixes into our environment and bringing up our links. What I want to do is I want to talk about this idea of metrics and demonstrate the fact that certain values are going to be required to be matched in order for us to be able to form adjacencies. So let's start with this. We'll start on R1. Now on the confines of R1, what I'm going to do is I'm going to say config T, router, EIGRP, and we'll go ahead and use 10. And I'm going to say network, and I want to advertise 172.16.1.1. And let's see, 10.1.101.1. Do show IP protocols. And what we're going to see here is a number of values that I want to take the opportunity to kind of entertain. Now when we look at this, the first thing that we're going to see is we're running EIGRP process, or Autonomous System 10, not process. I'm hooked on OSPF, so I keep bouncing back and forth. And what we're also going to see here is some other values, like for instance, outgoing update filters, incoming update filters. It's going to give us values or configurations that have been applied against our EIGRP configuration. But where I want to focus on right now is going to be this idea of metrics. Now, with regard to our metric configuration, as we discussed in our theory, our metrics have to match in order for us to form adjacencies. Now, it's not necessary that we have ones in each of these. However, it is normal for us to have a default setting of 1 for both K1 and K3. Now, the others are going to be set for our values with regard to 0. So that means that our primary methods that we're going to use to calculate our metric is going to end up being bandwidth and our delay. Now we can manipulate those values, but right now what I want to do is just focus on a normal basic setup. So let's bring up the rest of our environment and see if we can't get everything up and operational. So what I'll do is I'll cut immediately over to Cat1 and do my matching config. Show, run, interface, show, IP interface brief, E assigned. So what we want to do is set this up on 101, router, EIGRP 10, network 10.1.101.11, and network 10.1, let's see, this one's going to go to 10.1.2.10.11, which is going to go up to Cat2. So let's switch over to Cat2, that one's going to go up to R2. Let's see if we can't get this one configured. Show IP interface brief, exclude assigned addresses. And now what I want to do is config T, router, EIGRP 10, network, and we need 201, so it's going to be 10.1, 201.12, and network 10.1, 203.12. So I just configured this link and this link, and this link and this link going up to R2 and R3. So now let's go over to R2 and R3 and do the configurations to R22. So en config T, show IP interface brief, E assigned. So we need to go down to, on R2, we need to go down to see, 203, that's not right. See something here. Show CDP neighbors. SW3. or EW3. Yep, it's this one right here. So config T. I think I've got the wrong IP address configured. So we've got 10.1.203.2. So let's cut back down to cat 1. So it should be 210 show CDP neighbors. So we're connected to R2 via fast Ethernet 00. Do show run interface E00. So it's 201 show run interface VLAN 210. And that should be the address that I'm using. So when I cut over here to R2, I've got the wrong IP address. So interface E03, IP address 10.1.210.2. Router EIGRP 10. Network 10.1.210.2. So if I got this right, I should form a peering relationship with SW1, which I just did after I corrected the interface. And now what I need to do is bring up my connection to R22 on this device, which is going to be do show run interface serial 20. So network 10.1.222.2. Now let's cut over to R3 and do the same thing. Man, these are all out of order. Give me just 1 second here. Let me 3, 4, 5, 19, 20, 21, R22. So just to make my life easier, I'll go ahead and put this here and I'll drag the ISP to the end. All right, so now on R3, show IP alias, config T, router, EIGRP 10, network 10.1. Let's see, we need the connection to R22, so that's going to be 223.3. And we need the connection down to 12. So let's see, we've got, this is to 2 to 3, this is 203. So network 10.1.203.3. See what we got going on here. All right, so we have paired with with cat 2, which is .12, so everything's good to go there. So let's bring up R22, EN config T, router EIGRP 10, network 10.1.222.0, or let's see, 22. See if we form a neighbor relationship. And network 10.1.223.222. We should form a peering relationship through serial 2021. So now, show IP route EIGRP, we should see that we're learning the loop back on R1, which we are. So that address is going to be 172.1.0/24. So everything being equal in my topology, I will load share to reach that. So trace route 172.16.1.1, and we're load sharing. We're load sharing across R2 and R3. So with that being said, we've got our basic configuration. But the thing that I want to look at here is the information associated with this idea of metrics. Now, if I go into my basic configuration here and I mismatch my metrics, so like we said, show IP protocols, we see K1 is 1, 2 is 0, 3 is 1, K4 is 0, K5 is 0. And what we're going to do here is I'm going to manipulate this. So I'm going to config T, router, EIGRP 10, and I'm going to say metric weights, and my TOS is always going to be 0 because the type of service was not supported in the Cisco devices. And what I'm going to do is I'm going to change K1 to a value of 2, and I'm going to keep everything else the same. Now this should cause my links to go down. And the reason is going to be evident. It's going to be this idea of a K-value mismatch. Now, it's going to constantly be sending these messages out, so this information should actually refresh to give me an idea of what my problem is. Now, if this were to happen to us in the troubleshooting section of the lab, bear in mind that our logging to console in those devices in the TS section will be disabled. Now, that doesn't mean that we can't see that information. What we'd end up doing is we'd come up here and we'd do something like show log, and that's going to give us anything that's being recorded to the log. And as you can see in this particular configuration, I'm running both console and the configuration where it's sending things to the buffer. So this is going to be really interesting for us, and again, it's going to constantly send us this information. Now, what happens if I want to bring this link back up? Well, what I could do is I can match everything in my infrastructure to such that K1 has a value, a numeric value of 2, but what I'm going to do is I'm simply going to change it back. So let me take myself out of the equation here. I'm going to say config T, router, EIGRP 10, and I'm going to say no metric weights 100, or 0, 1, and what we'll see here is my adjacencies will return, show IP route EIGRP, and we're going to see information associated with these prefixes returning. Now, the other thing that I want to do here is let's try a few more show commands. Let's type a show IP EIGRP. See, we'll say 10 interface, and I want to say interface. Let's see, I'm on 22, so serial 1 or 2 0. And what we see here is we have the information associated with things like our pacing time, the mean smooth round trip time. We see the number of peers that we have on this interface, and we see some other elements, but we don't see a tremendous amount of stuff to give us a lot of concern. What I want to do is I'm going to say detail, and what I want to execute here is show S2/0. Now here's something that's really interesting for us. Notice it tells me split horizon is enabled on this interface. It gives me my hello interval and my hold down time that I have configured on this interface. Also notice here it gives me information about things like my authentication mode is not set. So just for illustration purposes, let's go in here and create another keychain. So we'll say keychain EIGRP_auth. Key 1, and I'm going to say key string IPExpert where the P is capitalized. Let's go to interface serial 2/0 and say IP authentication mode EIGRP 10 MD5. And then what we'll do is we'll also come up here and say IP authentication keychain EIGRP 10. And what I'm going to set up here is I'm going to say EIGRP_auth. Let's exit. Now what we see here immediately is my link is down, authentication mode changed. And what I want to do is I want to do repeat that verification command where I express the details command. Notice right now it's going to give me a lot of information. First of all, it's going to repeat the information we already looked at. Split horizon, my hold down intervals. But here's what I'm talking about. Authentication mode is MD5. The keychain that I'm using is EIGRP auth. Now notice retransmission sent, out of sequence received, multicast exceptions, CR packets, acknowledgments, unreliable unicast information. What we see here is that this information is indicative of the fact that this link, this connection to our peer is now down. So I just wanted to revisit that and bring it in because what we're going to end up talking about next is going to be how we can use a new operation inside the confines of EIGRP called named operation. Some organizations and some people refer to it as multi-address family or multi-AF EIGRP, but the term that Cisco uses, especially in their documentation, is named mode. And what we're going to find is it's going to introduce a lot of different elements or a lot of new components. Let's take a look at some last elements here before we dive out, because what I want to do is I'm going to comprise, or I'm going to illustrate the difference between something referred to as classic metrics versus what's referred to as wide metrics. Now, when we look at this, classic metrics are 32-bit metrics. But the problem is that in many of our new connection speeds, here let me bring myself in on the other side. Many of our new interface speeds are getting faster and faster and faster, and it's become more problematic for us to be able to calculate metrics based on these really high-speed interfaces. So modifications have been made to EIGRP to support this idea of wide metrics, where a wide metric is a 64-bit metric, which means now we have a mathematical capability to be able to illustrate or demonstrate the difference between things like interfaces that may exist on a Nexus versus something that may exist on, say, a 2900 series router like we have in the confines of the CCIE Routing and Switching version 5 exam. Now, the reason that we do this is so that we can actually have metrics that are going to be better representative of faster interfaces. Now, what we have to take into account is, like I mentioned previously, by default, the two metrics that we're going to look at are going to be bandwidth and delay. Now, when it comes to bandwidth, in the confines of our connections with EIGRP, that bandwidth is going to be measured in kilobits per second. What we're going to find out is our delay is going to be measured in something called microseconds. Now, let's take a look at something. If I wanted to manipulate a decision on an individual device as to which way I'm going to travel, let's look at what would happen if I wanted to be able to do that. Let me erase this. And what we're going to do is we're going to look at this on R22, because if I do show IP route, EIGRP, and hit enter, specifically let's look at one of these. Let's say show IP route 172.16.10/24. Whoop, sorry. Thought that I could. Nope, 255. iOS has ruined me. I'm sorry, NXOS. There we go. Well, right now what we see is I only have one link. That's because I have killed my other link. So show run interface serial 20. I've still got my authentication on. So let's fix that. Let's take that off. Config T, interface serial 2/0, no, paste. That should bring my connection back up. And now if I come back in here and say show run interface 020, it's gone. Let's take a look at what's happening with our route. Now I have the two prefixes, or the two ways to reach the same prefix. One through R3, one through R2. Now what I was illustrating here is let's look at our delay. Our delay is measured in microseconds. And also our bandwidth is illustrated here in kilobits per second. So those are two of the things that I definitely want to make certain that we are aware of before we move into a conversation about named EIGRP operation. Because what we're going to find is that when we go to named operation, the rules are going to change on us. And I want to make certain that we illustrate how those rules change. But the question now is let's look at this. Right now I see that I have two ways to reach this prefix. One of them is going to be through R3, one is through R2. And the reason that I have two ways is my metric matches. Now, one way that I could change this would be to go to one of these interfaces, config T, interface serial 2.1, and I could come in here and say, let's see, where is it? Bear with me just 1 second. I could manipulate bandwidth. I could come in here and say bandwidth and give this an arbitrarily higher bandwidth. Now what we saw is it defaulted to 1544. So let's say we want to change that. Let's say we'll default it to 2000. But keep in mind that's kilobits. So let's see what happens now. While it's defaulted, the whole idea is that with this manipulation, I'm just giving it time to do its thing. So let's see what happens now. Show, I'll just up arrow to my previous show command. Show my IP route. Well, notice what's happened is I'm picking serial 2/1 now instead of serial 2, 1, and 2, 0. And what I did is let's scroll back up here to where my config was. I went to 2.1 and I gave it a higher bandwidth. I gave it a bandwidth of 2,000 kilobits. So now what's ending up happening is that the system is using this as the way to go because the system thinks that it's faster. So what we'll do here is let's shut this off. So say config T interface serial 2.1 shut. And then we'll repeat our show command, and notice now it's picked 2/0. Now it's the metric here is and I'll go ahead and write it down. It's 2323712. So 2,323,000. Now let's go ahead and turn this interface back up. Repeat our show command. Neighbors come back up. Let's repeat it. 2,000 kilobits. And now notice our metric has changed. Our metric is now 6585491. So our metric is now 1 million because we went from 1544 to 2,000 kilobits. So the faster this value is, so the higher this value is, the lower the computated metric is going to be, and that's going to be that idea of the fact that our higher metrics are going to be inversely proportionate to, our higher values like bandwidth are going to be inversely proportionate to our actual calculated metrics. So higher numbers with regard to bandwidth is going to result in an actual lower metric computation. Now, when we go in and we do the rest of the manipulations on our devices, it's important for us to understand also, like I said, we have this idea of delay. Now, delay is going to be, like I said, measured in this value right here. Let me go ahead and grab my eraser. Our delay is going to be measured in a value of microseconds. Now, it's going to be measured in a value of microseconds when it comes to classic metrics. Now, again, those classic metrics are 32-bit metrics. Now what we're going to find is this microseconds is actually going to change to picoseconds when we look at our deployments using this idea of our, when we start looking at this from the point of view of being able to run wide metrics. So let me change my pin colors. So 64-bit is going to give me a wider mathematical computation than, say, my 32-bit metrics. Now, again, what we'll also look at is the idea of doing things like load sharing. Now, when we look at the system, let me change my bandwidth back. So, config T, interface, serial 2.1, up arrow, and we'll say no bandwidth in kilobits. See what happens. Show IP, we'll just up arrow and refresh. Show IP route. Now I've got both of those values in my config. Now that I've got both values, again, 1544, 1544. Well, let's look at another configuration here. Let's say config T interface serial 2/0. And what I'm going to do is I'm going to enter my delay, and notice my delay is entered in tens of microseconds. So again, if I take a look at my configuration, the screen shows me those values in, let's see, exit. It shows me the output in microseconds. But when I enter them, I'm going to enter them in tens of microseconds. So let's modify these. So what we'll do is we're going to go to the interface serial 1 or 2/0. And what I'm going to do is I'm going to give it a higher value. What I'll do is I'll come up here and say delay. And let's go ahead and give it a, let's see, the current delay is 26010. So what I'm going to do is I'm going to change it to 5,000, which is actually going to result, do show IP route 172.16.1.0, which is actually going to result in the route through R2 dropping out of the equation. Now, it dropped out of the equation because the metric is now bigger, the delay value, which means I'm going to now compute a different metric. So let's take a look and see what we have. So through serial 2/1, I have a metric computation of 232,30712. So 2,323,712. And my delay is 26010. Now let's take a look at what happens when I shut this link down. So I'm going to go to interface serial 2/1 and I'm going to shut down this interface. And then I'm going to repeat my show command, show IP route, and what we're going to see now is we have a completely different value. Notice we have a metric now of 3,091,712, and notice my delay was set up to 56010. Now this is kind of misleading because remember I went to my interface and I typed 5,000. The system is giving me more than 5,000. First of all, it's added a 0 to it because I entered it in tens of microseconds. So 5,000 tens of microseconds actually adds up to 50,000 microseconds. But the next question is where does this 6010 come from? And that's what I want to explore. Let's take a look at how this computation takes place on a link-by-link basis. So first and foremost, what we're going to find, and I'm going to go ahead and do a little bit of erasing here. And I'm going to remove my modification. So we did that under, see, let's no shut this interface. Show run interface 2/0. And I want to get rid of this command right here, the delay. Let me go ahead and erase some of this. All right, let's get rid of that delay command. No delay. If I hit up arrow now, I should have both prefixes being, or the prefix being learned through two different sources, R3 and R2. Let's do a trace route just to check it. And I'm load sharing. So this is everything that I want to be able to do, but what I'm trying to figure out here is why this value is being computed. So let's look at this from a device by device point of view. So let's go to R1. Show IP EIGRP. Let me do it this way. Show IP EIGRP 10 interface detail for LO0. And let's see what we have here. Well, let's see, what do we got? Well, I'm not seeing anything here. show IP, show EIGRP. Do I want to do the address family? No. Show IP, EIGRP, interface, detail, show interface LO0. Let's scroll up and see what we can find here. Right here it is. Notice it tells me for this interface I've got 5,000 microseconds. Let's take a look and see what we have here. This is for loopback 0. So this is loopback 0. So what I'm going to do is I'm just going to grab a pen, and for this interface, so for LO0, I have 5,000 microseconds. All right, now when we look at this, let's take a look at the interfaces, either interface that we're going to use to reach our destination. Now keep in mind our interfaces on R1 are going to be SVIs, or on Cat1 is going to, or Cat1 is going to be an SVI. So let's go to Cat1 and say show interface VLAN 101. And what I want to look at here is again, let's see if we can find our delay. Notice right here, our delay is 10 microseconds. So the loopback 0 interface on R1 has a value of 5,000. Cat1 says, well, to reach R1, I'm going to use my SVI interface 101, and it has, so SVI 101, it has a value of 10 microseconds. All right, so now what I need to do is figure out how do I get to Cat1? Well, I need to go to R2, and R2 needs to know how it's going to reach its destination. So show CDP neighbors. To reach Cat1, I'm going to go out Ethernet 03. So let's take a look at this. So show interface E03. I have 1,000 microseconds. So on R2, to reach SW1, I'm going to use interface E03, and it has a metric of 1,000 microseconds. And then lastly, what I do is I go to R22, and on the confines of R22, I know I'm going to use my serial interface, so show interface serial 2/0 to reach R2, and what I'm going to find here is that it's going to give me my 20,000 microseconds. So when I look at this, on R22, to reach R2, I'm going to use serial 2/0, and it has a delay of 20,000. So when I add these up, what do I end up getting? Well, I end up getting exactly what I got, or what I saw in my show IP route command. So show IP route 172.16.1.0, and I'm going to get a value of 26,010. That is going to be computed by taking my 20,000 to reach R2. R2 is going to take 1,000 to reach Cat1. Cat1 is going to have 10 to reach R1, and then what's going to end up happening is R1 says, well, it's going to be 5,000 to reach my loopback. Let me go ahead and just scroll up here. And that's going to give me a computational value of 20,56010, and that's going to be my total calculated classic metric to reach my destination. Do not lose sight of the fact that these metrics are going to be entered by us at the console in tens of microseconds. However, all of our output is going to show them in microseconds. So don't forget to do the computation. So if I wanted to go to 50,000 microseconds, I would have to say 5,000 tens of microseconds at the console. So with this being illustrated, what we've done is we've gone through and we've done a calculation as to how EIGRP is going to use bandwidth to affect how it reaches a destination and delay to determine how it can reach a destination, keeping in mind that by default, EIGRP is going to rely on those two values, bandwidth in kilobits and our delay in microseconds, in order to be able to do those computations and pick which prefix it's going to place inside of its routing table, or whether or not it's going to do load sharing. So with that being said, what we want to do next is we want to start looking at a CCIE routing and switching version 5 topic that's specific to the version 5 exam, and that's going to be named EIGRP operation. I'll see you guys in that video. Bye-bye.